Hope you can hear me. Good evening. So let's start the class. To start with, today main focus is on organic chemistry conversions. So we will be doing organic conversions mainly focusing on benzene today. Okay. Uh, I'll start with small, very simple conversions. Then we can move into the complex scenarios. I have opened the chat, and if there are any questions, you can ask from me. Right? Okay. Right. Let me share the screen. If I am, if my connection is not good, just let me know via chat. Right. I have opened the chat as well. Okay. All right. So let's. I will give you four conversions first. Try them, and you can mm, send your answers via WhatsApp or in the chat if possible. Right? I think chat is not possible for organic conversions, but you can use my WhatsApp number as well to send the answers. Right. So number one, first question: number of steps is not given. You can do the conversion with minimum number of steps. Okay. This is the first one. The second one is this. These are very simple conversions. First, I need you to understand the theories and how to do the steps, how to manage with these steps and everything. Get familiar with the regions. Right? Maybe you have done these things earlier as well, but at your theory class or so, wherever, but try them. I will give you some time. Right. Try these conversions, these four conversions. If there are any questions, you can unmute and answer. Sorry, ask any questions. Try these and let me know when once you're done. I'll be explaining those things. Huh? do this for conversions, then we can discuss. I'll be discussing those things. Do the conversions in the what you see in the screen, right? Okay, right. Mm, this this one has a problem, Pudha. We will explain, but there is a problem in your answer. Yeah, go on with the other ones as well. There is no defined number of steps for these conversions. You can use minimum number of steps. So no such guideline is given for this. Okay. පොඩි පොඩි වගේ පටන් අරගෙන අපි මේක ක්ලාස් එක දිගට දිගට යනකොට ඔයාලගේ ඕගනික් ටිකක් ඉවර වෙනකොට දඩ කන්වර්ෂන්ස් හදනවා අපි. සාමාන්‍යයෙන් ක්ලාස් එකේ ඔයාලට මම උදව් කරන්නම් කන්වර්ෂන්ස් 100ක් 150ක් විතර වගේ කොට දාගන්න. Right. Let's discuss. Okay. I think you have give it a try, but yeah, class එක දෙන්න ඕනේ. තේරුම් ගන්න. We will discuss, right? Now I will take the first one. So this is the conversion that you has been asked to do. Benzene converts into CH2 here, CH2, CH3, CH2, CH3. In benzene related conversions, Putta, you need to understand first where are the substituents has been added in the benzene ring. If it is a mono substituted benzene ring like this one. For an example, I will take X as a X as a like unknown one, right? So if X is activating the benzene ring, then X is a orthopara director. What are the orthopara positions is these two positions are called as ortho positions, and this position is called as para position. So if this X is an activator, it is doing an activation to the benzene ring. If X is a deactivator, like this, let's say Y is a deactivator, then it's a meta director. The meta director means the next substituent, next group which is coming to attach to the benzene ring will be directed to meta positions. These two positions are called as meta positions. So activators are orthopara directors, deactivators are meta directors. There is one exceptional case when chlorobenzene or chlorine or bromine is added to benzene ring. It is deactivating the benzene ring. It is deactivating the benzene ring, but it's an orthopara director. That is the exception. When chlorine or bromine is added, these are deactivating the benzene ring, but these are meta directors, right? Sorry, orthopara directors. Very sorry, orthopara directors, not meta. Orthopara directors. This is the exception. So, in general, activators are orthopara directors. Deactivators are meta directors. Exception is chloro and bromobenzene. This is called as chlorobenzene. This is called as bromobenzene. Even though this is deactivating, it is orthopara director. Now, how you identify activator or deactivator? I think you have discussed these things in your theory classes. If there are any unclear point to identify whether it is a meta director or orthopara director, I can explain it. Do I need to explain how do deactivators are orthopara directors and sorry, activators are orthopara directors and deactivators are meta directors? Do I need to explain? I think no, right? If needed, just let me know. That is coming from the mesomeric effect, right? That is coming from the mesomeric effect, right? So I think you can draw those resonant structures and everything. So if you can draw those resonant structures, that is coming from the mesomeric effect, you can understand why these are orthopara directors and why those are meta directors, right? Now here, if you check this conversion, you can see the substituents are added with compared to each other, they have been added to the meta positions. So the first substituent should be a deactivator. So we need to add deactivator and then get the other one into the meta position and try to get the final answer or the final component that has been given. So that should be the understanding of this conversion. First, you need to add a deactivator, not an activator. So deactivator will direct the next one to the meta position and check whether you have taken the final answer from that step. If not, continue to do the rest of the conversion until you get the given final result, right? So let's try to do this one. First of all, I need a deactivator which has two carbon atoms, because both positions are having substitution groups which has two carbon atoms, right? So I will add this one through Cradlecraft, right? Because benzene, addition of carbon atoms to the benzene can be done through the Cradlecraft, acylation or alkylation, right? Now I will do Cradlecraft, and via Cradlecraft I need a deactivator, right? So what shall I do is I will add a deactivator which has two carbon atoms here. You know, if there is a carbonyl group added to benzene ring, it will deactivate the benzene ring, right? Carbonyl groups are deactivators, right? So I have chosen this one through the Cradlecraft. So for the Cradlecraft, you know, we need anhydrous AlCl3 as well. Then the end result of this one is C double bond O CH3. දැන් මේක ආතලයකට වගේ මෙහෙම ලියුවොතින් එහෙම if you have written down this one මේ කොළ පාටින් ලියන එක මෙහෙම ලියුවොතින් එහෙම this is wrong, huh? You should know which carbon atom is attached to the benzene ring. I have seen students are doing such mistakes. This is wrong because not the carbon atom, not the R group carbon atom is connecting to the benzene ring, but the carbonyl group carbon atom or carbonyl carbon atom is adding to the benzene ring, right? So you have to write down, you have to choose the correct structure, okay? Then this is the deactivator, right? Then I am adding the next substituent. It will go to the meta position, okay? So I need another two carbon atoms. If you check the final answer of this one, see, I have added something which has two carbon atoms and I need something which has two carbon atoms. So I will do the Cradlecraft again. So straight away I will do CH3 CH2Cl. I am not going for Cradlecraft as acylation. So I will go for alkylation then, anhydrous AlCl3. This will be directed to the meta position. C double bond O CH3, and this is directly directed to the meta position. Then the final result, I need the final result like this: CH2 CH3 CH2 CH3. So how to convert a carbonyl carbon or carbonyl group to CH2? That means, how can I do this one? What should I add here? What's the region that I have to use here? Carbonyl group, oxygen and double bond will be broken and two hydrogen atoms need to be added. Yes. එහෙමම කිව්වට බෑ. මට උත්තරේ දුන්න එක වැරදි. හරියට ලියන්න ඕන. Right? This is, you have to use Clemmensen region, right? Clemmensen region. Clemmensen region means what? Clemmensen. Clemmensen region. Clemmensen region is zinc amalgam and concentrated HCl. If you haven't write down these correctly, answers will marks will not be given, right? So this will be zinc Hg, amalgam is Hg, no, concentrated HCl, and you need to heat as well. Yes, concentrated HCl. So this is how you do this conversion. Okay, so we have used 3 steps for this conversion. Okay, yes, correct. You have given the answer for me. Yes, correct. Then the second one, don't worry that, don't think that this guy is doing very easy conversions, but I need you to understand the basics and I need you to do the simple things before moving into the complex things, right? Mama make a then you can do exam type questions, right? Actually, these are also like exam type questions, basically. But these are basic things. Sometimes basic things are also asked in the examination, right? So the next one is the second one I have given. Yeah, this one. Benzaldehyde. This is benzaldehyde. C double bond OH. I need to convert this into NO2 here, CH3NO2. Now, here also you can see each substituent group is connected to their respective meta positions. And the initial starting component is also a meta director because that is deactivating the benzene ring, right? It's deactivating the benzene ring. So I can directly add the next component or the next substituent to the meta position, right? So I need to do the nitration. I need to add NO2 as the next substituent. Then I will have this one. So let me take some more space here. C double bond OH, and I need to add NO2 to here. And you know what to do this one, what to do concentrated HNO3 and concentrated H2SO4 and heating. If you written down this one as HNO3 and H2SO4 without concentrated, that's wrong, right? So this will be concentrated HNO3 and concentrated H2SO4, and you need to heat. Heat is also should be there. Now NO2 will be added. Then try to visualize the mechanism of the nitration of a benzene ring. That's something in your syllabus, right? You need to understand how to do you need to understand the proper mechanism, how nitration happens through HNO3 and HNO2, concentrated HNO3 and concentrated H2SO4 while heating. And what is happening to the benzene ring after the nitration? After the nitration, benzene ring will be deactivated because nitrate group or NO2 group is a deactivated. Now after that, you can do this one in one step. You can apply Clemmensen to convert carbonyl group into H2. So 2 hydrogen atoms. Same thing that we have done earlier as well. Zinc Hg, concentrated HCl. Don't we want to write 50 degrees Celsius? If you can write down to the 50 degrees Celsius or 60 degrees Celsius, that's perfectly fine. But assigning delta mark or the delta sign would be enough, right? That would be enough. If it is 50 degrees Celsius, in some books it is at 60 degrees Celsius as well. That means for the nitration. Well, if you can remember this value 50 or 60, that's perfectly fine. But assigning delta mark would be enough. Okay. Right. Any questions on this one? I think no, right? Right. The next one. Next one is a bit tricky. Say I know that this is the conversion that you need to add. This is D means deuterium. That is the isotope of hydrogen. You know, there are three isotopes of hydrogen: hydrogen, deuterium, and tritium. H11, H12, and H13. So this is H12. D means H12. Okay, so CH2, CH3. මේ කරපු කෙනෙක් ඉන්නවද අතොස්සන්න බෑ? Digital විදියට අතොස්සන්න බෑ. So anybody has done this one? How to add D to benzene ring? Benzene ring or in any organic conversion is something very special thing. Okay, now D can be added in ඔයාලා දැනට කරලා තියෙන scope එකෙන් D can be added in two ways, right? One is through Grignard region. Let's say you have CH2C, sorry, I'm taking in a particular CH3 CH2Cl. If you add Grignard, right? So magnesium dryether, right? And then this is converting into this one. Then I'm adding D2O to here. Then this is converted into this one. This is one step to add D. Right? You know, these two steps can be combined together as well. Grignard region, addition of magnesium dryether and D2 addition, you can combine these two into one. So I can simply write down like this: CH2, CH3Cl. At the first step, I'm adding magnesium dryether. Second one is D2O. Then I can convert this into CH3, CH2, D. Additional question on Grignard: is it mandatory to add dryether? What is the usage of dryether here? Yes, okay, that is mandatory. Why we need to add dryether? What's the reason? Yes. Yes. Good. Both answers are correct. One answer is otherwise it will destroy with hydrated conditions. That is also good, correct. Other answer is wet medium can react to form another species. That is also correct. Both are correct. Because we need to have some cool and calm and quiet environment. නිකන් අර සාමාන්‍යයෙන් කෙමිස්ට්‍රි වල ඩ්‍රයි ඊතර් දානවා කියන්නේ පන්සල් ගියා වගේ සීන් එකක්. සද්ද නැතුව ඉන්න ඕනේ. Right. So no other interactions. වටපිට බලන්න බෑ. ගෙයල් ළමයි දැක්ක කියලා එහෙම හැරි හැරි බලන්න බෑ. You have to focus on your work. Magnesium is very hard to handle. Magnesium, when he looks at chlorine, it is like අර මියගෙට ගංගවත් මොකද්ද මේ ගං වතුර වැටෙනවා වගේ තමයි. බස බස ගාලා ගන්න තමයි බලන්නේ. Magnesium is very reactive. But we need to control magnesium. Right. That's why we are adding dryether. And also we need to make sure, magnesium need to make sure whether he need to attack to chlorine, and magnesium need to make sure that there are no other species that can attack to chlorine. Right. මේක වැඩිපුර ඉන්නේ එළමයිනේ. කොල්ලෝක දැනගන්න ඕන හොඳට. If there is a target, there should be no other competitors for the target. If there are targets, if there are any other competitors, they should be controlled with some other medium. Supporter කෙනෙක් ඉන්න ඕන. So that's why dryether is coming there. Dryether makes the peaceful environment, and it is making sure that only magnesium will be approached to the chlorine. So that is why we need to apply magnesium with dry ether. Otherwise, we can apply magnesium only. That's okay, right? So this is one occasion or one point that we can apply D. Other one is through Clemenson. So when you have something like this, Futa, CH3, C double bond or CH3 something, I am applying zinc Hg, zinc amalgam. I am applying concentrated DCl, not HCl. Then the end result will be CH3, CD2, CH3. So these are the two occasions where you can add D to the organic conversions. Right? Instead of concentrated HCl, you can add DCl. Now here, you can see this D is in this conversion is added to a single position. It is not any other else. So definitely this should be with through chlorine, right? This should be through chlorine, right? Because you need to add chlorine first and convert it into magnesium Grignard region, then add D2O DCl, whatever species which is having D, right? And on the other hand, each other is in the meta positions, right? So let's try to do this one then. I'm having benzene here. I need to convert this into D and CH2, CH3. First of all, it's clear this D is coming through chlorine or bromine, right? That is clear, not through Clemenson, because Clemenson should have another carbon atom, right? Because Clemenson we can only apply for aldehydes or ketones. But if D is alone, that is through Grignard, definitely it is through chlorine or bromine. Now, tell me, am I going to add, do we need to add chlorine first here or any other species first here? Should I add chlorine first? Yes or no? අපි මේක ඉස්සෙල්ලාම add කරන්න ඕන chlorine because D is coming through chlorine. That is very clear. My question is, should I add chlorine as the first substituent for the benzene ring? Good. Yes. අනිත් අය මොකද හිතන්නේ? I should not add chlorine first. Should not. Why? Chlorine is a deactivator. I told you earlier. It's a deactivator, but it's a orthopara director. So if I add chlorine first, the next species will be directed towards the ortho or para positions. But I need to add the next one to the meta position. So I should add one of the species who can direct the next species to the meta director or the meta position. So whatever the species that I am adding first should be a meta director. That's a basic idea. Okay. Now I need to add this fellow first. But this fellow CH2CH3 is an activator. Why CH2CH3 is an activator? What's the reason? Why it is an activator? You can simply say it's through the mesomeric effect, but why? I'm asking some additional questions just to brainstorm your organic knowledge. Why I can't directly add CH2 CH3? Because it's become an activator, right? It's very clear chlorine is not the first one. It should be the blue highlighted one should be added first, but it should not be CH2 CH3. It has been converted from some other species, right? So why CH2 CH3 directly can't be added? Because it's an activator. I'm asking, yes, I'm asking why it's an autoparadigm, why it is activating the benzene ring. That's my question. Why? I activator connect CH2 CH3. Your answer is not not acceptable. It's not. Yes. Why I can't add CH2 CH3 first? Because CH2 CH3 is alkyl group, right? This is an alkyl group. You what are alkyl groups? Put C2, sorry, CnH2n plus 1. These are alkyl groups. CH3 is an alkyl group. CH3 CH2 is an alkyl group. CH3 CH3 CH2 is an alkyl group. Alkyl groups are electron repulsive groups. It is repelling electrons towards the other fellow. So whenever it is attaching, benzene, when it is attaching to the benzene ring, CH3, it is repelling electrons towards the neighboring carbon atom, which is towards the benzene ring. So that's why it's an it's behaving as an activator to the benzene ring. That's a simple answer. So my question was why CH2 CH3 is activating the benzene ring? Because it's an alkyl group. Alkyl groups are electron repulsive groups. So therefore, whenever it is attaching to the benzene ring, they will activate the benzene ring. That's a simple answer, right? So that's why I can't go for CH2 CH3 first. Then I need to go for a deactivator with 2 carbon atoms. So it should be through the acylation. So I will add this one. Oops, I need some space here because I'm going to add this one, C double bond O CH3. So this is CH3 COCl and hydroxyl Cl3. Then I'm adding chlorine, right? So chlorine can be added with Fe dust, and I need to heat. This will direct chlorine to here, right? Then I'll be converting this one into CH2 CH3 by using zinc amalgam. This is converting into CH2 CH3 and this is Cl. Then I'm going into the process of addition of D. It can be done through Grignard, right? So one step it can be done as the first step. I am adding magnesium triether. The second step, I'm adding BClO D2O. So this is the simple thing that we can do for this conversion. We can do this one in 4 steps. 1, 2, 3, 4. Yeah, 4 steps. So this is how you do this conversion. This is actually exam question. Yeah. මේ ඩ්‍රයිත එක කොච්චර magnesium ඩ්‍රයිත කියන කොච්චර strong ද කියනවා නම්, right? It can replace this chlorine. It can replace this chlorine actually. It helps to replace this chlorine. Can you remember in mesomeric effect, right? When you draw the resonance structures, 3 out of 4 positions or 3 out of 4 um, resonance structures are having a double bond between benzene ring and benzene ring carbon atom and chlorine atom. Can you remember? Now we need to use the Kekulé structure for this. It is starting from here, the chlorine atom, like this. Then a lone pair will be going through this, and this will be broken towards this side. And there will be a double bond here, and minus charge will be here, like this. So if you can see, so see, this is a double bond here. So actually in 75%, I'm not going to draw all, you can draw all at home. But if you complete these resonance structures, right, out of 3 out of 4 positions or 3 out of 4 resonance structures are having a double bond in between benzene ring and the benzene ring carbon atom and the chlorine. So it can detach this double bond. This Grignard region can detach this double bond and substitute D. So magnesium is that much powerful with chlorine. That young darling young that much powerful chlorine. Sorry, magnesium and chlorine. They match each other very well. Right. So this is how you do this conversion. Any questions? All right. Okay, next one. I need to convert this one into CH2, CH3 and Cl and CH3. Okay. Okay. So if you haven't learned this step, Uta, this is a very popular step actually. The benzene ring can be added with chlorine or bromine through chlorine or Fe dust, or you can do chlorine and FeCl3. Sorry, chlorine plus FeCl3 while heating. Any of these two can be used to add chlorine atom to benzene ring, but chlorine with Fe dust is preferred. Can you try this one? I will give you some. There is another question. As I know, Fe dust is not in later syllabus, right? Instead, we use FeX3, right? No, Fe dust is still used. FeX3 also can be used. Both of them are acceptable in the syllabus. That is in both of the steps are acceptable. Fe dust is not that much effective, but it can be used. Both of them can be used. Okay. I can show it in. So I'm not. It is not here in my laptop. I will show in the next week. I have seen this one in the teacher's handbook. Make Karan ba this one. Now I have done few. No, once you're done, just let me know. Then we can send me the answer via WhatsApp or like in the chat or in your else. Sorry, I don't have that one here. I will show it next week. If you have done, just let me know. Now you have the weapons for this. Okay. Let me reply to you. Yes, this is good. Your answer is correct. So I do this one. I can start from actually there's a meta director, right? So in such situations, there is something in ortho position, sorry, para position and meta position. Remember, start from the meta position. First, add the meta director and add whatever the things next to the meta position. Then add to the para position or ortho position, right? If there is a meta position, meta position substitute, just add it at the first step. Okay, theory का किधर माता का दिया है, right? Right. So I will add the meta director first. So CH2, CH3O, you can add, here is another answer. Okay. Yes, good. This is also good. Very good. Right. So I can add CH3 related one or CH2 CH3 related one as the first step, right? It doesn't matter, okay? Because you can't add chlorine, obviously. Chlorine is the orthopara director, right? So I will add CH2 CH3 one first. Okay. Mm. Your one, Puta, there's bit a problem here. This one here, right? Let me show you. So if I add CH2 CH3 first, actually this is the orthopara director. I can't add this one first. I need to add meta director first. C double bond to CH3. Then I will add Cl2 FeCl2 or FeBr, FeCl3 or Fe dust. Then this will go to the meta position. Okay. Then after that, you can convert this one into CH2 CH3, that is through zinc amalgam. CH2 CH3 and Cl will be there. And next add CH3, that is through alkylation, right? Priddle-Craft alkylation. Then you can add CH3Cl, anhydrous AlCl3, and you can heat, right? So this is how you do the conversion. Okay, good. ගොඩක් අය හොඳයි. ඉවර අය මේක try කරන්න. By using CH3 C triple bond CH synthesis CH C double bond C CH3 CH3, right? Make කරන්න බා. Try to do this. This is not double bond. This should be a triple bond. Yes. Mm, yeah, actually, the second region that you have added has to be formed from the initial component. That part is also need to be mentioned because you can use the initial component to form what you have added in the second step. Yes, this is correct. Good. Okay. So let me do this one, right? So yes, let me show. Yeah, your answer is partially correct. Let's see. Huh? So what I do is um, it's clear that this number of carbon atom has been doubled. 1, 2, 3 here. 1, 2, 3, 4, 5, 6. So doubled. So the addition also should be through the terminal uh, hydrogen atom or the acidic hydrogen atom or acidic alkynes, right? So first of all, I will convert this into CH3, C triple bond C, Na plus. Now I'm not going to write the regions. Huh? Regions you have to find. Okay, as an exercise. Then I need to add this one, the sodium one, through Cl or bromine atom, right? So what shall I do is I will convert this one into an alkene first, right? So alkynes can be converted into alkanes through H2PT quinoline or barium sulfate, right? Poisoned H2PT. Then this will be converted into CH3, CH double bond, CH2. Then I will add HBr to here, right? When I add HBr here, it will be CH3, Br will come here. I have explained this one in the previous class how this HBr is heading. Then what shall I do is I will add these two, right? Sodium and bromine will combine together, and this carbon atom will be added to this carbon atom. Then the end result will be, I can write this part like this, C CH3 CH3 like this, and hydrogen, and the rest of the part with the triple bond will be added to here. This part is adding to here, right? So this is how you do this one, this conversion. No need to add anything in the final step. For this step, nothing need to be added. They will react together very easily, right? For the for this step, I have not written down the regions. It's up to you to find the regions. Okay, right. Any questions on this one? Okay, there are no questions. We will conclude the class. Okay, that's a question. Don't we need to add barium sulfate? Yeah, phenolene is basically barium sulfate. You can, instead of H2PT, sorry, instead of quinoline, you can add barium sulfate. That's okay. Quinoline is also accepted. Uh, Quinoline is the name of this poisoned barium sulfate mixture. You can simply say quinoline acid, or you can say barium sulfate H2PT. That is also correct. Okay, if there are no other questions, let's conclude the class. The next class will be on Friday. Friday, I'll be discussing inorganic cation analysis or cation identification questions, chemical calculations, energetics, and gaseous state. ඔය වගේන් ගණන් එක හෝ දෙක ගානේ හදනවා. Then that is on Friday, this Friday 10 p.m. right, ඒක ටික ක්ලාස් එක ඇදෙයි. Friday ක්ලාස් එක ටිකක් මේක වගේ නෙමෙයි ටිකක් ඇදෙයි. ඕගනික් එක මේ වගේ පොඩි පොඩි වලින් පටන් අරගෙන මම ලොකු ඒවා හදන්න පටන් ගන්නවා. ඔයාලගේ ඕගනික් ටික 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 ඉවර වෙගෙන යනකොට. Right, theory, I know that theory classes are still ongoing. So there are some other students who are not yet completed organic or started organic as well. So if there are if there are students like that, I can help them. Just let them know, and let your friends also know. I'll be doing this class until your exams. Gradually, this will be converted into past paper discussion, and also this will be converted into model paper discussion as well. Okay, gradually. මුල් මාස දෙකේ විතර වගේ තමයි මම මේ වගේ කරන්නේ. Then this will be converted into a proper paper for past paper discussions. ලොකු ගණන් හදන class එකකට මේක convert කරනවා. Right, free class, anyone can join. Okay, so let's stop the class from here for today. Thank you very much. Good night. Right, see you on Friday. Okay, thank you. Good night.